Point north. Right now. Without a compass or looking at the sun, can you do it? Maybe you have a vague sense, but you're likely off by a significant margin. Now, consider the European robin. Each year, this bird, weighing less than a single AA battery, flies thousands of kilometers from Eurasia to Africa and back. It navigates with pinpoint accuracy over oceans and unfamiliar terrain, often at night. It isn't using landmarks it remembers. It possesses a sense we can barely comprehend, an internal compass that is fundamentally alien to our own experience. The secret seems to be located in a bizarre place: its eyes. Specifically, inside the bird's retina are molecules of a protein called cryptochrome. You have cryptochromes too. In humans, they are part of the machinery that governs our circadian rhythm, telling our bodies when to sleep and when to wake. They are our internal light-sensitive clocks. In the robin, they also respond to light, but they do something else, something that, until recently, was thought to be impossible in a living organism. They can apparently detect the Earth's magnetic field. To understand how, we have to abandon the world we know. When a particle of blue light from the sky enters the bird's eye and strikes a cryptochrome molecule, it triggers a quantum event. An electron is jolted from one part of the molecule to another, creating what is called a radical pair. Think of it as two molecules that are now magnetically unbalanced, and crucially, their single, unpaired electrons are quantumly entangled. Their properties are linked in a way that defies our everyday intuition. They form a single correlated system, a delicate quantum compass needle that lasts for mere microseconds. This is where the planet's magnetic field plays its role. The Earth's magnetic field, while vast, is incredibly weak. Yet it's just strong enough to influence this fragile, entangled state. Depending on how the bird's head is aligned with the Earth's magnetic lines, the field will subtly alter the spin of these electrons. This change affects how long the pair remains entangled, which in turn determines the final chemical products of the reaction. This process generates a signal that is sent to the bird's brain. The result isn't a feeling of north. The bird literally sees the magnetic field as a pattern of light and shadow superimposed over its normal vision. But this entire idea seems impossible. Quantum states like entanglement are notoriously fragile. Physicists build multi-million-dollar laboratories cooled to near absolute zero to protect these states from the slightest disturbance for even a fraction of a second. A living cell, by contrast, is a warm, wet, chaotic storm of vibrating molecules. Any delicate quantum connection should be destroyed instantly by this thermal noise. This is the problem of decoherence. And yet, the evidence suggests that in cryptochrome, the entanglement lasts just long enough, about 100 microseconds, for the chemical reaction to complete and provide a directional reading. This isn't just accepted fact. It remains a frontier of active research. But the clues are compelling. In laboratory settings, scientists have found that exposing migratory birds to a weak, oscillating magnetic field completely scrambles their navigational sense. The field is too weak to affect a physical compass, but is tuned to disrupt the spin dynamics of a radical pair. The birds, suddenly lost, begin hopping in random directions. This doesn't prove the theory, but it's a powerful piece of evidence suggesting that whatever this compass is, it operates on principles that are not classical. It appears to be fundamentally, unavoidably quantum. So the robin flying past your window isn't just a part of biology. It's a quantum mechanics experiment. It's using the spooky, non-local rules of the universe's smallest scales to achieve something monumental. Its brain is processing information that was generated by entangled electrons inside its own eyes. This blurs the line we've drawn between the strange world of physics and the familiar world of living things. It makes you wonder, what other quantum strangeness have we overlooked, hiding in plain sight within the machinery of life itself?
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.